In logic, a quantifier tells us how many elements satisfy a property. We already know that universal quantifiers means for all or for every. This means for every x, p of x is true. And on the other hand, existential quantifier means there exists or at least one. This means there exists at least one x such that p of x is true. So what are the nested quantifiers? Nested quantifiers happen when you use more than one quantifier in the same statement. For example, this means for every x, there exists a y such that p of x, y is true. And now things get interesting because order matters a lot. And this is the most important rule, that order of quantifiers changes the meaning completely. Compare these two. They look similar, but they are not the same. Suppose p of x, y is equal x less than y. For case 1, this means for every number x, there exists a number bigger than that. Is this true for natural numbers? Yes, because for any number x, choose y equals x plus 1. There is always a bigger number than a natural number. So it is true. And for case 2, this means there exists one number y that is bigger than every number x. Is that possible in natural numbers? No. There is no biggest natural number. So this is false. Hence, just swapping quantifiers completely changes the truth. So what's the visual way to understand? Think like this. This means each x can have its own y, different y for different x. And this means one single y must work for all x. That's much harder. And nested quantifiers have some negating rule as well. These are the golden rules. These two rules can be seen similar with De Morgan's law, except here quantifier flips and inside becomes negated. For example, if we want to negate this expression, at first we flip universal quantifier to existential quantifier, then we flip the inner existential quantifier to a universal quantifier. Besides this, nested quantifiers depend on the domain. Domain matters. For example, in this expression, if domain is real numbers except 0, it is true. But if domain is integers, it is false. For example, if we say x is 2, then there exists no integer that can be multiplied with x and it results 1. For xy to be 1, if x is 2, y must be 1 by 2 or half, which is not an integer. So we cannot say domain is integers for this x and y. So this is a short basic understanding of nested quantifiers.